All right, here comes practice number 3. It's about a meteorologist. A meteorologist claims that the average wind speed in their city is 8.0 miles per hour. A sample of 24 days has an average wind speed of 7.6 miles per hour. The population is normally distributed with a population standard deviation of 0.6 miles per hour. Okay. At alpha equals 0.01, is there enough evidence that the average wind speed is not 8.0 miles per hour? Okay, so we're going to go through the steps here. A couple things, and you see the null hypothesis already. A couple things here. So they mention here that alpha equals 0.01. In the last problem, alpha was 0.05. That's going to be the typical. One thing to be aware of, the smaller the value of alpha, then the smaller that shaded region is. So in the last problem, our shaded region was way up here, right? And it represented the top 5%, 0.05. Well, if we were to change that to 0.01, then that moves it even further down, right? So if 0.05 is like, if that's where we draw this line, then 0.01 is going to be way further. So that means it takes even more evidence to reject the null hypothesis. Just something to be aware of. You see larger values of alpha as well. So the smaller the value of alpha, the more evidence you need. And alpha is always decided before you start investigating. If you are a statistician, you don't go through your calculations and then pick alpha. That would not be good. Okay, so let me get that off the screen. And let's go ahead and read and go through the rest of the steps. So if the null hypothesis, we're going to assume that the wind speed really is 8.0 miles per hour, like the meteorologist says. And it's going to take a good amount of evidence to show otherwise. Exactly how do they phrase it? It says, is there enough evidence that the average wind speed is not 8.0 miles per hour? So all we're going to say, and I think you saw it just a second ago in a flash, we're going to make our alternative hypothesis mu does not equal 8.0. We don't know if it's a little bit higher or a little bit lower. All we're asked to investigate is, might it not be 8.0? Okay. Now we also see the average wind speed from the sample, but that's not what we're asked to look at, right? Just, is there enough evidence that the wind speed is not 8.0? Now this has a big effect on the alpha, as we were talking about. There's more to say about alpha here. If you don't equal, here's what's going on. Let me give you a drawing before we go any further. They said alpha is 0.01, okay, which is in it already. That's a small significance level, 1%. If you make the bell curve, right, we put mu at the middle, 8.0. But now, because we're talking about does not equal, it might be higher or it might be lower. So what we have to do, we take that alpha and we have to split it. Half of the alpha goes above, the other half goes below. So when you have a does not equal, you take half of your alpha and make it at the top. The other half of your alpha, you put it at the bottom, because when you look at your sample data, if you land up here, that's enough evidence, and if you land down here in this shaded region, that's enough evidence. A statistician would know that going in. They would know if this is going to get cut in half or not, so they would adjust accordingly. So if they know they want, you might argue this is really, the 0.005 is really the significance level, but because it's high and low, we put it together and we just call alpha 0.01. When you read the problem, know that that alpha needs to get cut in half, a little above, a little below. We would refer to this as a two-tailed test. Use alpha over 2 in each tail, right? The upper tail, the lower tail. Okay, so that's going to be important when we get to step 4, when we compare the p-value and the significance level. Okay, let's move on to step 2. Step 2 is to calculate the test statistic, otherwise known as the z-score. Okay. So remember, we're looking at the formula as in the central limit theorem. Okay. We're assuming that mu equals 8.0. That's the null hypothesis. What is x bar here? X bar is the sample average, right? And they said the sample average was 7.6. Okay. They told us the population standard deviation 0.6, and they told us n, the sample size, is 24. Okay, so we'll plug all these in. You may notice, hey, the sample size is 24. That's less than 30. Is that a problem? But it also says that the population is normally distributed. That's okay because it's normally distributed in the first place. So it's all right if we pick something less than 30. Okay, let's go ahead. I put all those numbers in. 7.6 minus 8.0 divided by 0.6 over the square root of 24. And I rounded to 2 places. I got negative 3.27 as the test statistic. All right. So make sure you get that number. You may have to throw parentheses around numerator and denominator. We've done a lot of these by now, though. A lot. Okay, let's go to step 3. It's the p-value. So we're going to find the probability that goes with this p-value. Okay. So we'll set it up. The p-value equals the probability that capital Z, is it key moment, very important step. Is it a less than or a greater than our z-score of negative 3.27? So I told you in the last problem, always look back to the alternative hypothesis and it will match. But there's a problem here, right? The alternative hypothesis was a not equal. Oh no. But we have to have a greater than or a less than. But I look back here and it's a not equal. What do we do? Okay. If that's the case, then look at your sample average. Is your sample average bigger than or smaller than mu? Look at the comparison there. We can't use this. And here, the sample is less than, right? 7.6 is less than 8.0. So we're going to use a less than. The two-tailed test, right? It might have gone either way. The sample might have been bigger, might have been less. It turned out it was less, so we use a less. Okay. Hopefully that makes sense. Let's go on. You're going to use your Statcrunch Calculator. Actually, Statcrunch, they give you lots of decimal places, right? For some reason, I've got 5. I guess it's more accurate than 4. The table of z-scores only gave you 4, but the calculator is a bit better. Okay, so it's 0.00054. That's what I got. I don't know if I rounded that number in the table or in the calculator or not. Okay, so we've got the p-value. Step 4, we're going to compare the p-value with the significance level. here's where it comes in, where we needed to divide it in half. Okay, so we're comparing to alpha over 2, 0.005. Okay, so we got our p-value 0.00054, alpha over 2. Since it's a two-tailed test, 0.005. Which one is bigger? Clearly alpha over 2 is bigger. Even dividing it in half, it's still bigger because this is so tiny. So what does that mean for step 5? Step 5, you call it, you make the decision, decide, do you reject the null hypothesis or do you fail to reject the null hypothesis? Well, if alpha over 2 is bigger, then it's the opposite of that first example we did, practice problem. This one we do reject. Let's talk about why. This is maybe another way to ask it graphically. I've got my bell curve again. I've got my two shaded regions again, both with alpha over 2. Does p equals 0.000, right? 54. That was my p-value. Is that fall inside the shaded region? You think, okay, we're looking on the left side. 0.00054 would be way down here. I mean, you're talking not even 1% would be 0.01. It's what, it was a 1%, a tenth of a percent is like 5/10 or 5/100ths of a percent, something like that. I mean, it's tiny. That's the sample average of 7.6. Way down there. So yes, it definitely falls inside the shaded region. So we have the evidence. We reject the null hypothesis. Guilty. And it doesn't ask for it in the problem, but I'm going to give you the interpretation in words. There is enough evidence that the average wind speed is not 8.0 miles per hour. Notice in the interpretation, we don't say anything about the 7.6. All we say is there's enough evidence that it's not that. We got so far down here, the chances of us taking a sample and the average coming out to be 7.6, a sample size 24, is so minuscule that this probably wasn't really the average in the first place. Okay. There's a lot of logic going on. I totally get that, but hey, that's why we have Zoom sessions. All right, we're going to stop this video here. Read about the student T hypothesis test, and you might read about the proportion-based hypothesis test. We're going to look at those two practice problems in the following video if we have time to do both, or it might be two separate videos. See you there.